Hi everyone, this is Delbert speaking, and today's class I will show how to obtain the seasonal components of the time series previously presented. So we have here the algorithm, the aforementioned algorithm, and here we have the number of the months, the number associated to the months of our time series. So it goes from 1 to 6 because we have 5 years of data. And I put here more 12 values, which is associated with the next year. We will use our seasonal components in order to forecast the next year. Okay, and then we have the year associated, the year of our time series, 2012, 2013, 2014, 2015, 2016, and the next year that we will forecast our time series. The month, January, February, March, and so on. The number associated with each month, so it goes from 1 to 12 for each year of analysis. Here we have the energy consumption and the energy consumption divided by 1000, because in this way we have smaller values and it makes the process easier to work. Okay, let's start by computing the moving average of the time series. So we will start by the month 5 because it is more or less in the middle of our period of analysis, which is 12 months. So let's start here, and we want to compute the average associated with these 12, the first 12 months. Okay, so we can do this for all period of analysis, and we need to take care that if you drag down for the last month, you will have blank data. So this is an undesirable situation, so we need to remove the moving average, which was computed with blank data. This one. So this is the last data that we can compute without blank. This is the last result that we can compute without blank data. Okay? So now we can see how the moving average fits with the original time series. We can compute, or we can show it graphically. Okay, so in red we have the moving average, and in blue we have the original time series. I will call seasonal components, and I will use this graph to show how the results associated with the models fits with the original data. Okay, because we are working with even numbers, we have 12 numbers, we compute the moving average for each 12 numbers. We need to center this data, and it would be between the month 5 and the month 6, between May and June. So to do this, we can compute the moving average for each two results associated with the moving average previously computed. Okay, and we can do this until this point. Okay, so we don't have blank data. Now we need to change this graph for the center moving average. Okay, now we have a center moving average associated with the data set. And we, in our algorithm, we are here. We centralize the moving average. Now we need to compute the additive and the multiplicative model, and the index associated with the additive and the multiplicative model. Okay, let's do for the additive model, and then we can do the same for the multiplicative model. First, to compute the SAI, this stands for Seasonal Additive Index. It is computed by subtracting the original data by the moving average. Okay, we started by this point, because the moving average is started by this point. So we can do this for all months. For all months until the end of the moving average. Okay. Now we can compute the average value associated with the seasonal additive index model. As we have different values for each January, for example, we need to compute an average, and then we have a representative value for this month. Okay, I will show here how can we do this. So we need to compute the average if I will see this interval, which is the interval where we have data available from this point to this point to this point. You see, this is the last point that we have available. So the average, I put here F4 because I will do the same for the next months. The criterion for the first month will be, it should be equal to 1, and the interval of the average will be computed from this point to this point. And F4 here, F4 here. Average if, let me see, this point to this point, F4 equal to 1, and the interval will be this interval, F4, F4, and we have the representative value associated to January, regardless the year that we are computing, because this value is an average value associated with all January. So we need to do the same analysis for all months. And here we change for February, March, April, May, June, July, August, September, October, November, and December. Okay. So as these seasonal additive index are representative for all months, we can copy and paste exactly the same values for the other years. So let's copy and paste for the other years. Copy and paste and paste. And then we have the same values for each January, for each February, and so on. Because the sum of these values are different of 0, which means that these seasonal additive index are unbalanced, which is not desirable for the time series analysis. We want the same quantity above the moving average and below the moving average. We need to balance this seasonal additive index, and to do this I will present a technique by using the PowerPoint, and then we go back to this timesheet, to this spreadsheet, to implement the idea. Okay, so I will stop the video now and I present it on PowerPoint. Then we go back to this table. So the idea is to adjust the components and obtain 0 when we sum all components, which means that we are with index associated with seasonal components balanced. So the main objective is to sum, I will call the index seasonal additive components equal to 0. This is the idea. We know that now they are different of 0. And to obtain, or to make this expression true, let's sum a delta value in each indexes, and then we will obtain 0. To do that, let's consider that delta 1, delta 2, delta 12, they are all equal to delta. It means that ISA plus 12 delta would be equal to 0, or should be equal to 0. And then the delta value will be minus the sum of all components divided by 12. So we will compute the delta value and we will apply it in this expression in order to obtain new additive components. And as a result, we will have the sum of all these components during the year equal to 0. Let's see how it will be done by using our spreadsheet. Okay, let's go back to our table. Okay, now we can use the idea of the adjustment of the seasonal index and apply it here. So to do this, we will use the previous seasonal index and we subtract the sum from this point to this point, the 12 values, F4, F4, and then we divide it by 12. And we need to do the same for all seasonal index. And now we have the average equal to 0 and the sum equal to 0. Okay? And copy and paste for all years in our time series. So now we need to compute the model by using the indexes or the seasonal components and the trend components. The trend components we have presented in the last class, and it can compute it directly from here by the equation associated with our time series, which is this equation. So let's put this equation here. So it will be equal to, here we have the slope, and we need to multiply each month by this slope and sum with the intercept, which is 43.08. Okay, and we can do this for all period of analysis. Finally, we can compute the values associated with the additive model in this column. And how can we do this? We sum the trend component with the seasonal component for each month. We can do this for all period of analysis. So I will put these results, the results associated with our additive model, into this graph, and we can see that if it fits well with if it fits well with the original data. So let's do this by selecting the data with this name and this set, this data set. As you can see, the model fits well with the original data set. And I will show how can we extrapolate it for the next year, which is one of the objectives when you use a statistical model for adjust with the original time series. But before that, let's do the same for the multiplicative model. So I will put this graph aside and let's compute the multiplicative model. First of all, we compute the multiplicative model by dividing the original data by the moving average, the center moving average. Okay. So we do this for all period of analysis, and then we have the seasonal multiplicative index. And the same idea should be done to compute the representative values of the multiplicative index. The same idea used in the seasonal additive model, we will do for the seasonal multiplicative model. So we just need to change this column for this column. Okay. And then we drag down until the month 12, and we need to change it. 1, 2, 3, 4, 5, which is March, 6, June, 7, July, 8, August, 9, 10, 11, and the last one, December. So those are the representative index for each month, regardless the year that we are analyzing. So I will copy and paste the same values for all years. Now we need to fix the multiplicative index, and we need to do this because until when we sum all index for each year, we want to obtain this value equal to 1, the average of the values equal to 1, or the sum equal to 12. So I will stop the video. So let me show the idea of the adjustment for the multiplicative model. Let's start with the sum of each component. We want that this sum would be equal to 12, or the average of these values would be equal to 1. Would be it would be the same, it would be equivalent. The sum of the components equal 12, or the average equal to 1. So in order to achieve this, we need to incorporate delta element, which will be equal to 12, and delta 1, delta 2, delta 12, all of them equal to delta. So we know that delta would be 12 divided by the sum of each component. So let's apply it and see if it works. Okay, let's apply the adjustment in the multiplicative model. So we have the seasonal multiplicative index, then we need to multiply it by the sum. We need to multiply it by 12 divided by the sum from this point to this point. So F4, F4, and then we have the model adjusted for the first month, and we can do this for all months during the year. And now we have the average equal to 1 and the sum equal to 12. Copy and paste for all years. And finally, we can compute the multiplicative, the results associated with the multiplicative model by multiplying this point by multiplying the index, the seasonal multiplicative index, by the trend component associated with this seasonal multiplicative index. And we can do this for all months. And here we have the graph with the results of the multiplicative model. If we change for the additive model, we see that there is no big differences between both models. Now let's predict the next year. To do this by using the additive model, we need to obtain the trend component for the next year, and to do this we only need the number of the next months, which is 61 until 72. Then we have the trend component for the next year. The additive model can be obtained by the seasonal components which is equal to each month regardless the year, and we only need this information to compute the additive model for the next year. So the same idea can be applied for the multiplicative model. And then we can compute the values for the next year. So graphically, we have the results associated with the additive model for the next year, for 2017, and you can change the graph for the multiplicative model, and as you see, the results are quite similar. In the next class I will show how how we can compare both models, the multiplicative and the additive model, and see which is more appropriated for our application.